Hey guys, today we're doing chapter 11, section 5, which is on the factor theorem. So we've been spending a lot of time on factoring quadratics and other types of polynomials, but why? Well, the reason is that so we can focus on finding their solutions. So you may have noticed that when we're factoring these polynomials, we're coming up with what are called the roots, and those are the equivalent of the x-intercepts. So what is the solution to a polynomial? When we talk about solutions of polynomial equations, we want to know the zeros or the roots of the equation. The zeros are the places where the equation crosses the x-axis or the x-intercepts. These are places where our equation equals 0. So in other words, we're looking for the place where y equals 0, which is equivalent to the x-intercepts. So if I want to find where an equation equals 0, I can set that equation equal to 0 and solve using the zero product property. For all a and b, a times b equals 0 if and only if a equals 0 or b equals 0. So in other words, when we factor this quadratic into two different binomials, so something like x plus 7 times x plus 2, well, if we say that that equals 0, that means that one of those factors needs to equal 0. So what we can do is we can set them both equal to 0 and solve for each different root. So for example, we've got v of x equals 4x cubed minus 88x squared plus 480x. If I want to find the solutions to that, first thing I'm going to do is factor out a 4x. So when I do that, I'm left with x squared minus 22x plus 120. Okay, then I can factor this quadratic using my x game. So I know I'm looking for two numbers that multiply to 120 and add up to negative 22. And I figure out that that's negative 12 and negative 10. So now I've got 4x times x squared minus 12x minus 10x plus 120. I can factor by grouping. So here I can pull out an x, and I'm left with x minus 12. Here I can pull out a negative 10, and I'm left with x minus 12. So then when I factor this, this is 4x times x minus 10 times x minus 12. So now I can use my zero product property to figure out what the actual solutions to this equation are. Well, I know that if this equals 0, then that means that either this needs to equal 0, this needs to equal 0, or this needs to equal 0 because they're all being multiplied by each other. So I can just solve each part. So if 4x equals 0, well, to solve that, I would just divide by 4, and I would get x equals 0. If x minus 10 equals 0, to solve that, I would just add 10 over, and I would get x equals 10. And if x minus 12 equals 0, I would just add 12 over and get x equals 12. So that means that the zeros in this case are going to be 0, 10, and 12. And your factors are going to be 4x, x minus 10, and x minus 12. Okay, the factor theorem says x minus r is a factor of a polynomial p of x if and only if p of r equals 0. Okay, so essentially what we can do is we can think about this r here being our 0, and if I plug that into my equation, I should get 0 out. So this is kind of a way that if they ask you, is this a 0 of your function, you can go through and check pretty easily without actually solving your whole equation. Sometimes we have polynomial functions that cannot be solved by factoring. We can solve these by graphing instead. So for example, we want to find all of the solutions of x to the fourth minus 14x cubed minus 87x squared plus 1080x by graphing. And then we want to rewrite the function in factored form and graph on the same axes. Okay, so if I want to do this by graphing, the first thing I'm going to do is graph this on my calculator. So on my calculator, I'm going to go into my y1. I'm going to type in this equation. Okay, so I've got it typed into my Y1 now, and I'm going to change my window. For this one, I'm going to change my X values to go from negative 25 to 25. I'm going to change my Y values to go from negative 5,000 to 5,000. So once I do that, I get a graph that looks like this. Okay, so now remember that what you're looking for in your graph are your x-intercepts, so the places that your graph crosses the x-axis. So if I want to find those x-intercepts, you can do a couple things. You could use table, or you could do second trace, and that number 2 there is 0. Okay, that'll give you the zeros. So if I go to my zeros, it's going to ask me for a left bound and a right bound. For each of those places that it's crossing the x-axis, you're going to want to do this. So I'm going to start with the furthest to the left, do my left bound and my right bound, and my guess, and I get x equals negative 9. So that's my first 0. I'm going to do this again, do my left bound and my right bound, and I get x equals 0. Do it again. This time I get x equals 8. And last one, x equals 15. Okay. So now I want to go through and actually find the equation, and I want to graph it on the same axis just to check and make sure that I've done it correctly. So if I know that these are my zeros, I need to be able to rewrite these as factors. Well, using that factor theorem, it says x minus r is a factor of a polynomial if p of r equals 0. So in other words, if r is a 0, I can rewrite it as a factor using x minus r. So this first one here, x equals negative 9, I can rewrite that as x minus negative 9, which is the same as x plus 9. This one, x equals 0, I can rewrite that as x minus 0, which is just x. X equals 8, I can rewrite that as x minus 8. And then x equals 15, I can rewrite that as x minus 15. So now I just want to make sure that I have the correct equation, and I'm going to just graph this on the same axis. So on my calculator, I'm going to hit the y equals button, and under y2, I'm going to leave my original function in there, and I'm just going to enter this in for y2. So x plus 9 times x minus 8 times x minus 15. All right, now I'm going to graph it. And you should notice that it doesn't change anything. It's still the same exact graph. That's because we've done this problem correctly and we factored it using graphing. And that is everything for section 5.